In this video, I'm going to show you how to use the Mass Spring Vibratory Virtual Lab. First, I'll go over the layout of the systems and their menus. Then we'll see an example simulation and the different ways to view the output data. Lastly, I'll compare output data from two simulations. This virtual lab is made using MATLAB Simscape, which lets you build systems using different mechanical components. For example, this external force block, which applies the step or harmonic force, as well as the objects interacting with each other, like the solid block that represents the mass. When you open the file, this is the first screen you see. There are 5 modules with different configurations of masses and springs. To pick which module to run, you have to click its title, which is in blue text. The box under it is then highlighted, like so. To change the parameters of the selected module, double-click the highlighted box. The window that pops up is where you will enter the parameters. Note that MATLAB will only run the highlighted module, so you must select the blue title before double-clicking a new module to enter its parameters. When you have the correct module highlighted and its corresponding window open, there are 3 tabs of different parameters. Variables such as mass and spring constant, free response where you can apply an initial displacement to the mass, and force response where you can apply a step or harmonic force on the mass. Also in the force response tab, there is a checkbox labeled 0 initial displacement. When it is checked, the sliders that control the initial displacement of the masses are disabled, and the displacements are set to 0. Unchecking the box enables them again. Likewise, in the free response tab, the checkbox for 0 forces disables the forces options and sets the values to 0. This means there will be no force acting on the masses. Unchecking the box enables the force option again. You must click Apply at the bottom of the window to apply your parameters after every change. Otherwise, an unapplied changes error will appear if you run the model. Update and Run will open the Mechanics Explorer window, which visualizes the system. The buttons above the tabs allow you to control the simulation from the window. The Update Model button reloads the model after parameter changes are applied without running the module. Run Simulation will run the module. Note that while the simulation is running, changes cannot be made to the Simscape model, and even if you apply parameter changes, the rest of the current run will not take those changes into account. For example, if the mass is set to 2 kilograms when the run starts, changing it to 4 kilograms will not change the mass mid-run. Stop simulation will end the current run, though you will still have access to the data loaded until that point. Open Scope Plot opens a new window that shows the displacement of each mass versus the simulation time. Each module has the same layout, though the modules with more than one mass also have an Open Frequency Plot button, and the 2 mass modules have a Mode Ratios button that calculates and displays the mode ratios in the Free Response tab based on the simulation data. After a simulation is done running, you can analyze the output displacement data of the masses using the Scope Plot, Frequency Plot, or Mode Ratio buttons. All the displacement data is also automatically saved in the MATLAB workspace within the out variable. Out.position 1, 2, or 3 reference the position in centimeters of the corresponding mass. Out.tout is the simulation time. To compare 2 different system simulations, first save the output data of the first system simulation with a variable name. Then run the second simulation. Now you have both sets of data readily available, and you can use this process to save and compare many different systems.